Welcome to part 2 of the Calculus Semester 1 exam review odd problems. Mr. Wolf working them out cold turkey without having looked at them before. Find out if I really know what I'm doing here. Again, I'm going to do every other one because the answers are posted and because I don't want to take the time it takes to work all of them. So how about that? You could do the same if you do the odds and you feel comfortable with it, then that's probably fine. If you want to be best prepared, then do all of them. All right, no calculator. So this, in theory, should go a little bit quicker because I don't have to punch stuff in. We'll see. Which is an equation of the tangent line at x equals 2. So already I'm thinking f prime and a point, and at 2 would be f prime at 2. Point is 2 comma something. For the graph of y equals 6x squared minus 12x plus 1. Oh, I like this one. This should be easy. 12x minus 12 for a derivative. If I plug in 2, I get 24 minus 12 is 12. So there's my slope. I need a point. 6 times 4 minus 12 times 2 plus 1. That was nice of them. So my point is 2, 1, and my slope is 12. So already I could throw out some of these. And actually I could just go see which one of these gives me 2, 1 as a point. And that's the only one that does. So working forwards, working backwards a little bit, kind of meet in the middle, as opposed to y minus 1 equals 12 times x minus 2. Multiply it all out, and you would land right there anyway. All right. I said I was going to do the odds, but the 26 has a bunch, so let's do every other one, keeping in the spirit of the law here. As n goes to infinity, so that's the top no, bottom o equal co thing, or just when things get really, really big, 500n doesn't really matter. The only thing that matters are these two terms, and those would reduce to 5 halves. B is the same thing, or similar thing. C, top no, bottom o equal co, or x squared gets really, really, really big compared to just 5x. So this goes to 0 because the bottom's getting bigger. I don't want to skip D because it looks like f of x plus h minus f of x. So this is the derivative of f. Well, f is 5x to the 4th. F prime then is 20x cubed. So that limit, not from algebra but from recognizing calculus, is 20x cubed. X approaches 5. This is a factor and reduce problem, although that's kind of tricky because those reduce to -1. So -5. I'm guessing that was another reduce problem, factor and reduce. Here's another set this up. This looks like the derivative at pi, where f is sine of x at x equals pi. H looks different with that e to the x in there. Let's plug in 0 and see what happens. E to the 0 is 1, minus 0, minus 1 over 0 squared. 0 over 0 is no good. I think this is a L'Hopital's rule, which we haven't done yet. So here's your bonus for watching the video. You know how to do that one. This one, I know sine of x over x equals 1. So if I can make some things match up, put a 4 there and a 4 in the top, and then take the 12 out front, that's just going to be 12. Limit exists, function exists, g is continuous. Well, the definition of continuity is the limit exists and the function exists and they're equal to each other. So this is very much a related question here. I want to take the easy one first. G of 2 exists. Yeah, because g of 2 is equal to 3. So statement 2 is definitely true. So anybody that doesn't include 2 is out. So I need to know if 1 is one of them and if 3 is one of them. Limit as x approaches 2. Well, factor and reduce. X minus 2 goes away. By goes away, we mean there's a hole there. Then we could plug in 2. And so that means the limit as x approaches 2 is 4. So the limit exists, it equals 4. Basically, there's a hole at 4. But the function is at 3. So it is not continuous. So limit exists, function exists, but they're not equal to each other. So 1 and 2 only. (29). Let's see. Ooh, horizontal asymptotes. That's when x approaches infinity or negative infinity. That's why we might get 2. If I plug in infinity, I'm going to get, that's the top no, bottom O equal co thing. I get negative 2 because I'm ratio of the coefficients. If I plug in negative infinity, I also get negative 2 because if I square negative, it goes positive. So I do not have 2 horizontal asymptotes. I have 1 horizontal asymptote at y equals negative 2. No, not no horizontal. So 1 horizontal. Vertical, it'd be factors of the bottom that don't cancel. So 2 and negative 2. Neither one of them cancels, so I have 2 verticals. 2 vertical, 1 horizontal. Tricky question there. Inflection points, that would be second derivative equals 0 and changes sign, so be careful about that because I think this one, the second derivative is going to equal 0 but not change signs. I'm almost positive of that. 8x cubed minus 8. Second derivative is 24x squared. So it's going to equal 0. Y double prime equals 0 when x is 0, but it doesn't change signs because it's always positive. So no points of inflection for b. 31. Limits. We should be good at these, I think. As x approaches negative 3, function approaches 0. Whoops, negative 3. The function approaches 2. That's what I get for saying these would be easy. But f of negative 3 is down here at negative 1. Limit as x approaches 0 is different from the right or the left, and 1's going to infinity, so that's a D and E. F of 0 is 2. Limit as x approaches 2 from the right would be 1. 2 from the left would be 2. 4 from the left would be negative 1. 4 from the, no, just 4 overall. Well, there's a difference there, so that's a D and E limit there. 4 from the right would be 0. I guess sort of those two things put together is why it's D and E, because it's different left and right. And then f of 3 is 0. Estimate the coordinate where f of x equals 1. That seems a weird question, but that'd be right there at 1, 2, 3, negative 3 point something. And right there at negative 1 point something. And right there at 1, 2, 3, 4 point something. Kind of a weird question. Limit as x approaches 5. 1, 2, 3, 4, 5. Tricky. That's D and E because we don't know what's going on over here. If we come in from the right, there is no right to come in from. (32) looks easy. 33. Oh, inverses, inverses, inverses. So f and g are inverses, x and y, y prime. So we want the value of g prime at 2. So that means that x is at 2. That means the y value for f is 2. And if we can get that derivative, we'll just flip it over to get what we're really looking for is this answer, g prime of 2. So I need to know where the function is equal to 2. So 2 equals 3x squared minus 2x plus 1. Set that equal to 0. Or move the 2 over. Hope that it factors. Let's see, x minus 1, 3x plus 1 would get me a negative 1 and would get me a negative 2x. So we're good there. So x equals negative 1/3 or x equals 1. Interesting. 2. Well, so I don't know if we should use 1 or negative 1/3. Hold that thought. F prime is 6x minus 2. Let's try 1 and see if our answer shows up. F prime of 1 would be 6 minus 2 is 4. And so the derivative is 1/4. So I'm thinking it's d 1/4. If we put in negative 1/3, we get negative 2 minus 2 is negative 4, and its reciprocal would be negative 1/4, and that's not a choice. So here we're using x equals 1. Implicit function, product rule, so on. Let's see if. Oh, that's pretty straightforward. For 35, f prime of 0. So 1/3 x squared plus 3x plus 6 to the negative 2/3 times, product rule, 2x plus 3. So 2x plus 3 in the top, 3 times x squared plus 3x plus 6 to the 2/3 in the bottom. Kind of a yuck question, but whatever. Plug in 0, we get 3 over 3 times 6 to the 2/3. So 1 over 6 to the 2/3. Straightforward problem, like those. 36 is straightforward. You just got to use the quotient rule. 37, at any point, the position of a particle, so this position, s of t equals that. What is the acceleration at 4 seconds? Oh, well, this should be straightforward. T squared minus 4t plus 3 is the velocity. The acceleration would be 2t minus 4, and the acceleration at 4 seconds would be 4 meters per second squared. Oops, feet per second squared. We like those questions. 38's another pretty straightforward question. 39, a lot of words. If g is a continuous function between negative 4 to 4, and g of negative 4 equals 2, and g of 4 equals 7, I think a picture might be helpful. So g of negative 4 is 2. And again, your picture doesn't have to be perfect, but it helps you visualize. G of 4 is 7. Which of the following must be true? The absolute minimum, the absolute maximum is 7. Well, not necessarily. Like we could go way up above. So no. G of x equals 5 for one value of x. Yeah, it's got to pass through there somewhere. That's the intermediate value theorem. So I'm pretty keen on D right now. G of x equals 0. Maybe, maybe not. So no. G is increasing for all x? I mean, maybe, but maybe not. Absolute minimum is 2. Again, maybe, but maybe not. So back to B. 40. Straightforward dy dx problems. None of those look crazy, so I'm going to leave those to you to do. Check the answers online. 41. Which is a line that can be used to approximate values near x equals 8? Ooh, I don't know that we've worded it like this before. But a tangent line could be used to approximate values. So let's find a tangent line to this function near x equals 8. So y prime is 1/3 x to the negative 2/3. So I need the slope at 8. Let's see. 8 to the 2/3. So the cube root of 8 is 2. 2 squared is 4. So 1/12. I don't see 1/12 listed over there, but I do see some 12, so I'm thinking those are probably it. So there's my slope. The point would be plug in 8 and see what you get. Cube root of 8 is 2. So y minus 2 equals 1/12 x minus 8. Granted, that does not look like any of those, but if we multiply through by 12 and move things around, x, so we'll leave the x there, subtract the 12y, add 8 to both sides, x minus 12y equals negative 16. So a little bit of calculus, a whole lot of algebra. (42). I want to answer this one. How many values of f appear to satisfy the conclusion of the mean value theorem? Which means the a rock equals the I rock. Well, negative 2 to 2. There's the a rock equals 1. So how many times, so how many places does the I rock equal 1? Well, somewhere around there it equals 1. Somewhere around there it equals 1. Nowhere else does it equal 1, so I would say 2 places. Average rate of change, we just found that. That was 1. (45). Use the intermediate value theorem to show that has a value of 9 some point on the interval 1 to 2. f of 1 is 2. f of 2 is 8 plus 2 is 10. Well, 9 is in between f of 1 and f of 2. So f of c equals 9 when c is between 1 and 2. And there's a couple ways you could word that, but it comes down to 9's in between 2 and 10, therefore f of some value is going to give you 9, and that value is between 1 and 2. (46). We said we could skip. Find the second derivative. So that's just second derivative and plug in things. That's not a bad deal. A local minimum of this function. So y prime would be, let's see, I'll slow down here. F prime is e to the x. G prime is 1. G f prime minus fg prime all over g squared minimum. So let's find where that's equal to 0, and then we can do a, I don't want to do a second derivative test, I'll do a first derivative test, a number line test. So we set that equal to 0. I can factor out an e to the x, that leaves x minus 1. By the way, this was on the practice AP exam we took. I can set both of those equal to 0, but e to the x is never equal to 0. So x equals 1. So let's check left and right. So if I plug in 0, I get 0 minus 1 over, can't plug in 0. Yuck. Well, the bottom's always going to be positive, so I think I can say that this is going to be negative. I plug in 2 to the derivative. I get 2e to the 2 minus e to the 2 all over 4. Well, I don't know what all that is, but it's definitely positive. So y prime is positive, f is increasing. So there's a local minimum at x equals 1, but the local minimum is f of 1. So that would be e. 48 is pretty straightforward. 49, mean value theorem. A rock equals I rock between 2 and 5, so I need the slope between 2 and 5, so I need f of 5 minus f of 2 over 5 minus 2, and I'll set that equal to the derivative of my function. So a little bit of side work to do here. F of 5, 5 minus 1 is 4, square root of that's 2, f of 2, square root of 1 is 1. So my A rock is 2 minus 1 over 5 minus 2. So 1/3 equals 1/2. 1 over the square root of x minus 1. Let's see. What do we want to do? I think I would put the square root of x minus 1 over here. Multiply both sides by 3. Square both sides and add 1, and double check, but that value better be between 2 and 5. Let's see, that's 2.25 plus 1 is 3.25. So, and there's my answer. At that x value, the I rock is equal to the A rock. 51, and final. Which of the following is true if f prime is that? Well, I'm going to shortcut this because I'm ready to wrap this video up. But if there's a squared, it's not going to change signs there. So there's not a local min or max at 0 or at 4. So I can guarantee you there's not a local maximum at 4 because it doesn't change. The sign doesn't change at 4. Local minimum at -3, not sure yet. Let's see. I plug in -10, I get positive, positive, because we're squaring them. -10 plus 3 is negative. F is decreasing, f prime is negative. If I plug in -1, I get positive, positive, positive. I plug in 1, I get positive, positive, positive. If I plug in 4, I get positive, or excuse me, if I plug in more than 4, 5, I get positive, positive, positive. And so, just as predicted, nothing's happening. 0 and 4 are not relative extrema. -3 is a local minimum, so 2 is true. F has neither a local max or local min at x equals 0. That's a true statement. It increases, levels off, increases again. So 2 and 3 for that one. Alright, if you made it that far, good for you. The entirety of the answers are posted, not with work shown, like this video, but they're all out there. So good luck. Feel free to send me an email, Schoology message, whatever, if you've got more questions. Thanks. Good luck. Happy holidays.